Okay, so we're going to look at some secant lines of functions. What secant lines are, if you remember from geometry, secant lines. Just draw a rough sketch here. Let me turn my pen on, excuse me. Obviously a secant line, if you're talking about a circle, secant line is just a line that intersects a circle at 2 points, as opposed to a tangent line that intersects a circle at 1 point. And a chord is the same thing as a secant line, except it begins and ends. So it's just a chord is just a segment, as opposed to a secant is a line. So you can extend that same idea to functions, where you can have a secant line that intersects a function at 2 points, and a tangent is intersecting a function at 1 point. We'll be looking at the secant of functions. So what we're looking at first is the average rate of change. Average rate of change is just a fancy way of saying slope. So the average rate of change is just your change in y over change in x. But notice in this case, as opposed to just finding the slope given 2 points, we're going to have a function of x. So therefore, in this case, we'll be finding the average rate of change of f of x from any value c, which in this case is -1, to any other value x. So this slope of the secant, so this stands for right here, slope sub secant, is actually going to is a function that generates the slope of a secant on f of x through x equals -1 and any other point. So I have a visual that we'll look at that'll help us get a better understanding of this. Okay, so the function we're looking at here in this problem is 3x squared plus x, and we're looking through the fixed point -1. So we're going through -1 and any other point. Here's the word other. I'm going to use the word other in a minute. So we're going to figure out this equation that we have right here is going to generate a function that'll find the slope of any secant line on the function that goes through -1 and any other point. So let's look at a visual. So here is our function, 3x squared plus x. So I've drawn it in here for you. And then here is a secant line that I've drawn, and notice that it's gone through -1, 2. And how do I know it's -1, 2? Well, I just took -1 and plugged it in here. And I got -1, 2. So this point right here is fixed. Let me just slide this over. So this point is fixed. So this one is not going to move. It actually might move as I drag this point along, but the idea is that this point is fixed and it's not going to move. And then here's my secant line that I've drawn, and it's going through this point right here, which is any other point provided that it's on the curve. So we can drag it around, and here's the ordered pair. Right now it's at 1.4, 7.2, and we can drag it along. We're actually going to, in a couple of minutes, we're going to want it to go through 2. And I believe it's 2, 14. So if I plug in 2 right here, f of 2, f of 2 is, I can't write on here. F of 2 would be 2 squared, which is 4, times 3, which is 12, plus 2 is 14. So 2, 14. So, but this point can be anywhere we want it to be. So it couldn't be at 2. Oops, could be at 2, or it could be down at 1. So there's 1, 4. So it could be there if you wanted to. And then we'd have a different secant line. And then obviously it can be also down at the origin. It doesn't really like to go to the origin that well. Let's imagine that that's at the origin and that the slope is -2. It says -1.98. So our first function that we will create is a slope generating function that generates the slope of any secant that goes through this fixed point and intersects the function at another point. So you notice I have this little piece right here, which is actually the slope of this secant line. Okay, so in this problem, what we're going to want to do is we're going to want to generate a function that finds any slope value that we want for a secant line that intersects this function at 2 different points. I have this already calculated for us, but we're going to do it using our average rate of change function on the Word document. So let's just go back to that. So therefore, our definition says take the function, subtract off f of c, where in this case c is -1, and then divide by x minus c. So my slope of the secant is equal to f of x, where f of x is 3x squared plus x. 3x squared plus x minus, well, what's f of c? Well, f of negative 1 is equal to 3 times negative 1 squared minus 1. So that's 3 minus 1, which is 2. So therefore this is 2 all over x minus c, where c is negative 1, so it's x plus 1. So we have to factor this numerator here. Since I know 3 is prime, I know this is going to be 3x and x, and then I need to get a positive 1 in the middle, so I'm not going to want to put a 2 here, because then that would give me a 6. That's too big. So I'm going to put the 2 and the 1 here. So I want a positive 1 in the middle, so therefore I want this to be a plus 1 and that to be a minus 2, and divide by x plus 1. What's convenient is you notice is these two cancel out. So when you're doing these average rate of change problems, if your denominator x minus c, or in this case x plus 1, doesn't cancel out, you did something wrong. Okay, so these should always cancel out. So this is 3x minus 2. So what we have here is the slope of any secant line that goes through x is negative 1 on the function f of x is generated by 3x minus 2. So this thing generates slopes. So the next one says determine the average rate of change. When I hear average rate of change, I think of slope. So find the slope that goes through negative 1 and also goes through 2 using the result from above. Well, this thing generates slopes provided it goes through x equals negative 1. Well, we've already have negative 1. So therefore we want to find the slope of the secant line that goes through negative 1. Well, negative 1 was used to generate this function. This function is only true for f of x. This slope generating function is only true for f of x and x equals negative 1 and any other point. Well, in this case, our other point is 2. So the slope of our secant, and I'm going to draw a vertical line in negative 2, and this is the same thing as function notation of f of negative 2, let's say, so you're plugging negative 2 in. So if I plug in negative 2, I get 3 times negative 2 minus 2, which is negative 6 minus 2, which is negative 8, and I didn't want to do negative 2, I wanted to do positive 2, my mistake. Let's try that again. So I wanted to do 2, so 3 times 2, so this is 6 minus 2, and that gives us 4. So the slope of our secant line that goes through negative 1, which was our fixed point, so this one was fixed, and any other point where the other is 2, our slope is 4. Well, let's look at our graph over here. I'm going to move, so our fixed point is negative 1 comma 2. Here is our function f. Here is my slope. I'm just going to move this over to make sure you can see it. I'm going to move my point other, up to 2. I believe it's 2 comma 14, which I just did a great job. And there it is. So notice that when I go through my x value 2 and negative 1, the slope that I got was 4. Well, I can do it one of two ways. I can have this graphing function in front of me, and it'll tell me any slope value of a secant line that goes through negative 1 at any other point. Or, if I want to know the slope value, I can use the average rate of change function, which this is a function that generates slopes. I can plug in another x value, and I can figure out the slope as well. So I've just figured out what the slope is of this secant line that goes through our fixed point, and then another point, which at this point is x equals 2. That slope is equal to 4. And I got the same thing here. The slope of our secant line at 2 is equal to 4. The next thing we want to do is figure out what is the equation of that secant line. So letter C says find the equation of the secant line containing negative 1, f of negative 1, and 2 comma f of 2 using the result from above. So in order to find the equation of a line, I'm going to use the point slope form, which is y minus y1 equals the slope x minus x sub 1. So my ordered pair is x sub 1 comma y sub 1. Well, so it's negative 1, and we already know f of negative 1 from earlier. F of negative 1 is, I think, 2. Yeah, it's right here. F of negative 1 is 2. So let's go back down. So we have 2, And what is the slope of our secant line? Our slope is 4. So slope is 4. So using this information, we do y minus 2 equals 4x minus a negative 1. So this is y equals 4x plus 1 plus 2. Y equals 4x plus 4 plus 2. So the equation of our secant line is 4x plus 6. So let's take a look back at the graph. And here is the equation of our secant line. So notice that this is a line, symbol of a line, going through the point other and fixed. The equation of that line is 4x plus 6. So that is the equation of this secant line right here. And we got the same thing right here, 4x plus 6. Okay, so what was the first step? The first step was just using the definition of the average rate of change, where this sets up a function that generates any slope value that goes through a given value -1 and the function f of x. So here's a slope generating function. We found the slope of the line that goes through the other point, which is 2. So therefore that gave us 4. And then we used our point slope formula to determine what was the equation of the secant line, which we got 4x plus 6 to be.